Hello friends, welcome to the session on data structure. In this session, we will be discussing about linked list. So, as shown in this slide, one can easily observe that linked list is basically a collection of nodes. Earlier to the linked list, we have already seen one data structure called as an array. And in array, we know that we can have a sequential collection of elements. But as far as arrays are concerned, you will find that arrays need successive memory locations. So, whenever you want to create any array in the memory, then you need a set of successive memory locations. But sometimes the memory locations are not available, particularly when the size of the array is very large. Then in that case, you will find that it is difficult to find the successive memory locations. And therefore, in such a case, it is possible that you can create a linear collection of elements as we do in array, and at the same time we do not require the successive memory locations. And this can be achieved by using the data structure called as a linked list. Also, one can easily observe that the size of the array is fixed and the size of the array cannot be changed. But linked list is such a data structure where the size is not fixed, and it is possible that we can increase the size of the linked list dynamically. So, that is can be done with the help of the linked list. So, linked list, like an array, is a linear collection of data elements where the elements are stored sequentially, and they are not stored in the successive memory locations. You will find that because of the structure of the linked list, we normally do not store them in the successive memory locations, but instead we can store them in different parts of the memory. So, every data element in the linked list will point to the next element. As shown in this diagram, one can easily observe that in the linked list we have a node, and there are two parts of the node. The first part of the node is being called as a data, and the second part of the node is being called as a pointer. So, this pointer will point to the next element of the linked list. There is one pointer that is being called as a head, and there is one pointer that is being called as a tail. So, every linked list will have two additional pointers. One is called as a head, which normally points to the first element of the linked list, and there is another pointer called as a tail, and that will point to the last element of the linked list. Now, head will point to the first elements. Suppose, as shown in this diagram, suppose my first element is 5, so of which the value is 5, and you will find that there is a link that is being provided in the first element, and the link will point to the next element. The next element is having the value 7, and there is again a pointer which will point to the next element. In this way, you will find that every element will have a kind of linking to the next element, and that is the reason this list is being called as a linked list. And finally, we have the last element of the linked list, of which the value is 15, and the pointer will point to null. So, the last element of the linked list will also hold a pointer, but the pointer value in case of the last element is equal to null. So, that indicates that there are no further element present in the linked list. So, now we will go further to understand how these linked lists are there. As I said, the linked list is basically a collection of nodes, and every node is consisting of two things. The first thing is being called as a data, and the second thing is being called as a pointer. So, the first element that is being pointed by the linked list is being called as a head, and the last element that is being in the linked list is being called as a tail. So, head and tail, these are the starting point and ending point of any linked list. Now, whenever we want to make an access to the elements of the linked list, then you will find that the access of the elements in the linked list is much easier when you compare it with the array, because in array the elements are stored sequentially in successive memory locations, and therefore, whenever I want to make an access to an element which is present in between an elements of the array, then you will find that we need to visit each and every element of the array in order to make an access. But the access of the linked list is much easier, as the element itself will contain the address of the next element, and therefore whenever we want to visit any element of the linked list, then the address is easily available. Also, the memory requirement is not continuous memory requirement for the linked list, but of course, since the linked list is consisting of nodes and every node is consisting of two values, data and pointer, therefore the memory requirement in general of a linked list is much higher than that of the arrays. So, you can say that linked list is a dynamic data structure. Now, which data structure we call it as a dynamic? The data structure that change or that can grow as the data goes on growing, then such a data structure is being called as a dynamic data structure. You will find that during the program execution, it is possible that the content of the linked list may go on growing, and therefore we can say that the linked list is a kind of a dynamic data structure where the list can grow during the execution of a program. Now, let us understand what we can have the different types of the linked list. There are different types of the linked list. The simplest type of the linked list is being called as a singly linked list or a simple linked list. So, this simple linked list is basically a collection of nodes, and every node will have a value and will have a pointer. As shown in this diagram, one can easily observe, suppose this is my first node having the value A, then there is a pointer next, and this pointer next point to the next element B, and again in the B we have a pointer, and this pointer will point to the next element C. So, this goes on, and the last element is suppose D, and suppose this is the last element, and therefore its pointer value is null. So, whenever we have a such type of the linked list, then such linked list is being called as a simple linked list, or sometimes we call as a singly linked list. So, as shown in this figure, the last pointer will have the null value, and in this linked list we can travel only in the forward direction. So, whenever we want to visit the elements of the linked list, then in this linked list we can traverse the linked list only in one direction, and that direction is called as the forward direction. That is, we will start from the first element, and then we will go to the second element, then we will go to the third element, and in this way we can visit each and every element of the linked list. Now, there are two more types of the linked list. Another linked list that is very popular, and this linked list is being called as a circular linked list. Now, suppose I have been given a simple linked list, and now what I will do is that the last element, if I connect back to the first element of the linked list, then in that case you will find that a circle is being formed, because the last element is being connected to the back to the first element of the linked list, and such a linked list is being called as a circular linked list, because the logical structure of this linked list is a circle, and such linked lists are very useful whenever we want to use them in the time sharing problems. So, as I said, linked lists are widely used in various applications. So, whenever we want to use them in the time sharing problems, then the circular linked lists are very useful linked list. There is another type of the linked list, and this is being called as a doubly linked list. And in the doubly linked list, you will find that each node will contain the two pointers. So, normally there is only one pointer in the linked list, but this is a doubly linked list where there are two pointers. One pointer is being called as a left pointer, and another pointer is being called as a right pointer. So, this is a linked list where you will find that the traversing or visiting each and every element in this linked list is possible in both the directions. In the simple linked list, we can traverse only in one direction, that is from first node or from first element to the last element. But since this is a linked list where there are two pointers, left pointer and right pointer, as shown in this diagram, then you will find that there are kind of two directions available for the traversing. Either we can go from the first element to the last element, or we can start even from the last element and we can traverse to the first element. So, both the ways, you can go in the forward direction and you can go in the reverse direction whenever you want to traverse the linked list. So this is a benefit, or this is an advantage of the doubly linked list. You will find that whenever we have certain data structure, then with the data structure always we can perform certain operations. And whenever we want to perform any operation on the data structure, we need to write down the algorithm, the proper algorithm for its operation. Because whenever we want to perform operations, then it includes certain set of steps, and these set of steps is being called as an algorithm. Now, as far as linked lists are concerned, we can perform the operations such as traversing. Traversing, as I said, that we can visit each and every element of the linked list. So such traversing operation can be easily performed with the linked list. It is also possible that whenever we have been given some linked list, then we can insert a new element into the linked list, and this operation is being called as an insertion operation. It is also possible that whenever some list is being given to you, and then you want to remove some element from the list, and this operation is being called as a deletion operation. So insertion and deletion, these are the most frequently operations performed on the linked list. Sometimes we have been given some key element, and if there is some key element given, then we can search the element in the linked list. So searching is also the most frequently performed operation on the linked list. In our next sessions, we will see how can we write the algorithms for performing these operations such as traversing, insertion, deletion and searching. Now let us understand how the linked list can be represented in the memory. Elements of the linked list actually do not require the successive memory locations. So this is the biggest advantage of the linked list. In case of an array, we require successive memory location, and linked list do not require successive memory locations. They can be stored anywhere in the memory. So wherever the space is available, in that part of the memory, you can create a linked list. And in order to maintain a linked list in the memory, what you require is the two arrays. So it is possible that you can implement the linked list by using two arrays. So one is being called as a data array, and another is being called as a next array. So data array will hold the value of the elements, and the next array will hold the pointer to the next element. So data array will hold values, and next array will hold the memory address of the next element. So linked list can be implemented by using arrays, because there is no default data structure provided by which we can create the linked list. So normally linked lists are created by using only arrays. So let us see one simple example how we can create a linked list in the memory. Suppose we have been given a linked list where the head is pointing to the first element, and the first element is having the value 13, and its pointer is 4, which will point to the next element. So the next element is holding the value 15, and its pointer is holding the value 6, where it will point to the next element. The next element is 19, and its pointer is 8, which will point to the next element. And the last element in the linked list is 57, and it will point to null. It means that it is a last element. Now such a linked list can be implemented in memory as shown in this diagram with the help of two arrays. This is the first array, which is being called as a data array, and this is the another array which is being called as a next array. So first the head will point to the first element. So the number 1, suppose this number 1 represents the memory address, and now this is the first element having the data value 3, and the next element is at memory address 4. So now here you can observe on the screen that on the memory address 4, the next element is there holding the value 15, and the next value is 6. So in memory address 6, you will find that the value is 19, and the next element will point to the next element holding the memory address value 8. At the memory address 8, you will find that the last element 57 is there, and its next value is 0, which indicates that this is the last element of the linked list. So thank you friends for viewing the session. Hopefully you have understood what we mean by the linked list, what are the different types of the linked list, and how it is possible to represent the linked list in the memory. Thank you all for viewing the session.